Hey there, welcome back to my channel. In today's episode, we're going to take our Telegram bot to the next level and talk about Finite State Machine. But before, let's take a look at the quick demo of what we're going to build in this episode. So if you start at the bot, you can see the following message: welcome to the developer survey bot, and it asks for your name. If you type your name here, like in my case, Almaz, it says, nice to meet you, Almaz. What's your favorite programming language? And here's the number of different options that you can choose from. If you try a random thing, a random string like this one, it will reply with, I don't know this language. Please select the one from the list. So now if I would try to choose the language, let's say I'm going to choose the Python, it will say, great choice. How would you describe your experience level? Now we try to use, for example, the senior. Here we go. And ask us to confirm the information. If we try reset, it will just reset the state of our machine. And we have to do this again. Our name on us, your language, your experience level, and confirm. Here we go. Thank you. Your response has been recorded. So this is the project that we're going to build in this particular episode. So up to this point, our bot has been reacting to simple one-off commands and button clicks. That's great for basic functionality, but as soon as you get a multi-step conversations, for example, filling out a form or asking the user a series of questions or building a small onboarding flow, it quickly becomes messy. And if you don't organize the logic properly, it will be really difficult to maintain the state. That's exactly where the finite state machine comes in. In this video, I will show you how to use a finite state machine in Aiogram library to manage multi-step dialogues in a clean and predictable way without turning your bot in spaghetti code. And as always, if you get stuck in your code or you want feedback on your implementation, feel free to join our Discord community. You can share your code, ask questions, or just show off your bot there. All right, let's jump into theory first. Why do we need the finite state machine? If you take a look at this slide, you can see that by default, bots are stateless. They don't remember if you are currently answering a question or just starting a new chat. The solution to this problem is finite state machines. Finite state machine is a way of remembering the current state of the user to organize and structure complex workflows. At any moment of time, the user is in one specific place, and depending on which state he is and the next message, we decide what to do and which state to move to the next. So you can think of it as a small map of your conversation. For example, a user might go through steps like from the non-state to registration, waiting for the name, waiting for the email, and so on. That's one of the simplest examples of application of the finite state machine. So basically at each step, the bot knows exactly what it is expecting, maybe a name, maybe a surname, number, yes, no answer, and so on. When the user replies, a finite state machine moves to the next state and runs the correct handler. Without finite state machine, you usually end up with a bunch of if-else statements, checks, and some other manual conditions spread all over the code. With a finite state machine, all this becomes much more structured. Every state has its own handler, transitions, and even in-memory data storage. So the main application of finite state machine is basically building multi-step forms, small wizards, onboarding flows, or any situation where you need to gather the data from the user. Let's take a look at the specific implementation of that. First of all, you have to define a new file. Let's say states.py to keep all our states in a separate module. In this file, we're going to define a new registration class. This registration class is basically a states group. It encapsulates all the states related to the specific workflow. If you have more than one workflow, you typically end up having more than one states group, depending on your needs. When the user starts the process, for example, sends a registration or any other command, we must switch their state. And for this purpose, we use a state argument of type FSMContext. So what is FSMContext? This is finite state machine context. It refers all the information related to the specific workflow of your finite state. In this case, it refers to the data which you collect from the user. For example, when user sends registration command, we reply, welcome, what is your name? And we essentially set the state registration name. So we are collecting the user's name and setting it in memory. Next, we create a handler that only triggers when the user is in the name state. We basically update our existing data with new additional information, in this case message text, coming from the user, which is his name. So let's take a look at this code snippet. In this case, when the user sends command register, we first send him a message, welcome, what is your name? And then we switch the state of the user to the name state. And now that we have switched it to user state, we implement a handler that only triggers when the user is in the name state that will process the name that user sends us. We can add additional checks or verification validation here inside this handler, but for simplicity purposes, I omitted this part here. As you can see, the state is being updated by the data coming from the user message text. Then we're responding with nice, I sent you an email, and move to the next step. We're basically setting the next step of the user registration email. Step number 4. In the final step, we get all the saved data and reset the user. For this purpose, we have a synchronous method, getData, that returns the dictionary with all the saved data that we have collected so far. We access this data by keyword arguments, and then we just send the message done, email saved, and then we just clear the state of the user. We can do whatever you want with this received data. You can call different methods, sending this data to the database or external API. Where is the data stored? First off, persistent storage. Persistent storage in this case could be Redis storage or any other persistent storage like database, NoSQL database or SQL database, it doesn't matter, but it should be persistent. In most cases, NoSQL keyword databases is being used. For example, Redis storage is quite a nice option because it provides high performance, high speed, and it is easy to get started with. And the other default way is using the MemoryStorage default option that is available when you just get started with a states group. It stores the data in random access memory. The problem with this approach is that if you restart your bot, all user states are lost. That happens because this user data is associated with a specific user session. So whenever you restart your bot, the session is closed and all the data have been lost permanently. In simple flows, it would be more than sufficient to use a simple memory storage. But if you have a more complex setup or user settings or configuration files, you should rely on a more persistent storage mechanisms such as Redis storage. So here's just a quick summary of the methods that we have associated with our finite state machine. We have set state, which sets a specific state to the user, update the data, set the data, get the specific data, or clear the state. We're going to cover all those methods in the context of this course. No need to bother remembering all of them. You will definitely pick them up on practice. And again, if you have any questions, feel free to leave them in the comment section below. I'm always happy to help you. All right, here we go. I'm currently in Visual Studio Code. Let's get started with our implementation. So the first thing I would like to do here is create a new file, which is going to be called state.py. So I just implemented a very simple states group. It includes 3 main states: the state name, a state language, and the state experience. When our user is in the state of name, we are asking for his name. If this user is in the state of the language, we are asking for his language. And if this user is in the state of experience, we are asking for his experience level, as you might have noticed in our quick demo at the beginning of this video. The next thing that we have to do is to adjust the logic of our keyboards and our handlers. I'm going to start with our keyboards. And here are the main keyboards that I have created for this purpose. I have created reply keyboard for our languages. We have 4 possible languages: Python, JavaScript, C++, and Go. I've also created the inline keyboards for junior, middle, and senior developer. And I've added inline keyboard for confirmation and reset. The one may be wondering, why did we use the inline keyboard markup in this case? Why can't we just handle this using a simple reply keyboard markup? Well, you can absolutely handle this using the simple reply keyboard markup. The difference comes from the fact how you are going to process this information in future. For example, if you have a specific format of data that your database must accept, in this case, the callback data looks like this, then you must use inline keyboards because its visual representation, which you show to the user, is different from the actual callback data that you are going to handle and process in your database, and your user is not aware about this logic. So that's why I decided to use reply inline keyboard markup. Now let's move on to the handlers and let's adjust them. First of all, I'm going to remove all the previous handlers that we had here, except start command. And then I'm going to refactor this a little bit. All right, so I removed some of our unused imports. And one thing that I have noticed here is that we have states, but our file is called state. Let's rename this to be states to ensure just consistency. That should be good now. Let me try this again, import survey. And now let's jump straight into the implementation of the remaining handlers. So I have added 2 main handlers. The first handler will handle the survey name state. In case when our user starts a bot, we set his state to the survey name, as you can see here. Then we move on to the next state. When our user in his name state sends us his name, we save this information to our in-memory storage and set the state to the survey language. After this, we are asking user for his favorite programming language. We are applying reply markup keyboard. And after this, the user has to send his favorite language. When the user chooses his favorite language, we are verifying that this language is actually in our list of possible options. It could be either Python, C++, or Go. And if our user didn't send the language which is permitted, we're replying with a message, "I didn't know this language, please select one from the list." Next, we update the state data with the language. And after this, we state the state to the experience. And once we have done here, we reply with a message, "Great choice. How would you describe your experience level?" And reply with the inline keyboard experience keyboard. Now we have to implement 3 more handlers to finish this workflow. All right, here we go. We have 3 more handlers. The first handler will handle the data, which should be prefixed with experienced, as we have specified in our handlers. Here it is. Then, if user in a state experience, and at the same time, the callback data starts with experience, we start processing his experience. We get the data from our callback data. For this reason, we split the message by the underscore and get the second part of it. Then we capitalize that, meaning that we convert the first character into uppercase. Then we are updating the state data as usual, and we are retrieving all the data that we have saved so far. We're displaying this data summary to the user so he could confirm all the data is correct. And then we added the existing message to avoid duplicating the message, to avoid cluttering the chat. And we're replying with a confirmation keyboard. Once the user confirms the information is correct, we send the confirm data callback data, and then we are going to trigger the callback confirm handler. This handler will clear the state of the user, update the existing message with the following text, and then just removes the reply markup keyboard. So this method is explicitly removing the reply keyboard. And then please keep in mind that we have to respond with await callback answer just to avoid the loading label at the top of our chat. And the final step here is if we need to reset the data and if our callback data coming from the user is preset data, then we just need to clear the state of the user, and that clears all the data with it. And then we have to edit our message and respond with the command start handler. So we are essentially invoking the command start handler inside our callback reset function. And of course, we need to respond with callback answer. So that's pretty much it. Let's see how that works. I'm starting the bot, and here we go. We can see what's your name. Let's see. I'm going to type my name, and now it should ask us for the favorite language, but it doesn't look like working. Let's see what is the issue here. So it looks like I have started 2 bot instances at the same time. Let me terminate one of them. So I just terminated one of the bots, and let's try again. I'm going to start the command start, type my name, choose the wrong language. It says I don't know this language. Now let's choose the right language and specify the experience level. Reset. I just now reset. Almaz, C++, Junior, and we have to confirm. And thank you, your response has been recorded. So everything seems to be working. And that's it for today's video. I really hope you found this video helpful. If you have any questions, feel free to drop them in the comment section below. And if you really like this video, hit the like button, subscribe to my channel, and see you in the next one. Bye.